If you do have any technical difficulties, you can reach out to me. So, with that, let's turn things over to Melissa.
Well, good morning, everyone. Thank you for joining us. Hopefully we'll be able to all celebrate and share in 50 years of the Clean Water Act today with some success stories and just different conversations. So I'm really looking forward to the FAQ when we can open it up and we can all share more information. So I put together a little presentation today on some of the information coming from the West Virginia Water Research Institute over the years. And I wanted to start off with just an overall background of the Water Research Institute history. So the Institute is actually under the Clean Water Act, under Section 104, under the Water Resources Research Act. And that's authorized to allow us to participate, working with different collaborators, state and regional entities to work on water issues within the state of West Virginia. So this program is run through the USGS, and there are actually water research institutes in 54 different areas, all of the continental states. And then there are a few territories that also have water research institutes in them. We are all housed at the land-grant universities within our state. So we're here at West Virginia University. And we've been around actually a little bit longer than the Clean Water Act, since 1967. We've been working within the state of West Virginia on water research related issues. Just to give you an idea of some of the programs that we have, we've got a critical materials division. We're also home to the Northern Brownfields Assistance Center. We have a mine land reclamation division as well. And that's what I'll start off with, just in giving you a brief overview of some of the things that we've worked on throughout the years. So back in 1988, Congress recognized the need for a centralized entity to sort of deal with national mine land issues. And we became the home for that center. So we've been working on mine land reclamation issues for some time now. Throughout West Virginia, we have a variety of different ways that we accomplish that goal. We work with West Virginia DEP, we work with various watershed groups, and here's just a brief overview of some of the passive treatment systems that we've been able to have constructed within the state. So we've got 22 different passive systems that we've worked on throughout the years. We've also worked with DEP on other issues, such as helping the Special Reclamation Division go through and prioritize and cost all of their bond forfeiture sites in effort to accomplish a remediation plan for those sites. So several years ago, we worked with them on that project and ended up identifying 135 sites that we ranked. We came up with a capital cost and operation and maintenance cost for those systems to allow Special Rec to effectively kind of plan out what they were going to do over the next several years. I think now with the bipartisan infrastructure law money coming in, we'll see more AMD remediation projects coming through. One of the big successes that we've had, and Jason Philhart, who's on the call, has been a big part of this, along with Tim Craddock at DEP, is out at Lambert Run. We've actually had several different sites that have been implemented for passive mine drainage remediation. Pretty significant costs going into that, but the end result will hopefully be in having that stream delisted from the 303D list in future years. This is just another overview of some of the behind the scenes in terms of matching funds that come in to be able to successfully accomplish these remediation projects. Sorry, I'm working from like several different screens here, so it gets a little confusing at times. Another thing that we've been working with DEP on is taking an approach at watershed scale remediation. So rather than going in and doing passive remediation at different points, but rather accomplishing watershed restoration by strategically placing dosers. So we worked with DEP down in the Cheat River watershed area, and strategically came up with places for dosers that would be able to accomplish meeting an overall goal of having complete watershed restoration. So this is just to give you an overview of some of the locations that we had put in some trial dosers just to see what that would look like. Eventually, DEP was able to invest and put in a centralized treatment system, and this was actually the first watershed-based national pollutant discharge elimination system, the NPDES point permit ever issued in the country. It's been a really big success in terms of providing a very consistent improvement of water quality in the Cheat River watershed. And we're pretty excited to have been part of that project. Another similar project with a watershed scale restoration was in the Three Fork area. And it was a similar combination of doser placement and strategically cleaning up that in terms of looking at the watershed as a whole. We've also been able to go in working with some of the professors here at West Virginia University and evaluate the success of that treatment. So they've done different ecological studies and looking at the socioeconomic benefits of watershed scale treatment and remediation. And here's a couple more slides just looking at, brook trout populations and showing the results of that watershed scale restoration. One of the other programs that we've had for a while that it's been pretty successful is our Three Rivers Quest project, and this is the one that I'm more intimately involved with. We've got 42 sites that we monitor in the Upper Ohio River Basin on a monthly basis, accumulating over 590 river miles that we're monitoring monthly. This started back in 2008, whenever we started getting reports from different water users along the river. Intakes were being clogged with salts. That led us to using some of our USGS funding to start monitoring routinely on the Mon, eventually branching that out to include the Allegheny and the Ohio. One of the things that we looked at through this was trying to figure out the source of the total dissolved solids or salts, trying to differentiate between what would be contributed by coal mines and what would be contributions coming from potential shale gas industry. We found that a lot of the issues that we were seeing in the Mon were coming from permitted coal mines. So that led us to meeting with different coal industry partners and ultimately developing a total discharge management plan, which was very successful in terms of lowering TDS in the Mon. This is just an overview of some of the data that we've collected throughout the project and being able to look at those chemical signatures to differentiate between what was coming from coal mining and what was coming from shale gas development. The success of that is that we were able to actually, if I had the timeline pulled up here, you'd see that our voluntary discharge management plan and working with the coal industry actually ended up resolving the issue of TDS and sulfate on the Mon before it was listed by EPA as an issue. So the total discharge management plan went into effect in early 2010. Later in 2010, it was listed on the EPA list, and then in 2014, it was delisted. And this is a pretty huge accomplishment in terms of being able to have that delisted. And we were able to provide our data to EPA for them to verify the delisting of sulfate contamination on the Mon. One of the things that we're just released is our beta version of our 3RQ mapping tool. I've got a couple links here for you guys to check out at your convenience. It's super exciting, and it wouldn't have happened without the hard work of some of our students and staff. You can get on there and choose our remediation projects. You can select layers for different industries. You can select layers for different sort of biological things and really sort of get an overview of what all is happening everywhere. And I'm sorry I'm talking so quick throughout this, but there's a lot to cover, and I could probably talk for hours about different projects that we've worked on throughout the years. But critical materials recovery is a big one that a lot of folks are interested in. Paul wasn't able to join us today to talk more in depth about our rare earth element extraction process, but it is something that's very exciting for the state of West Virginia in terms of being able to take our acid mine drainage sludges and recover rare earth elements from those. We've got a big project going on now at a pilot plant, going through that actual process, and we'll be super excited to be able to share additional information from that in the future. But I did include a link here. You can hop on our Facebook page. There's a really nice video that was done by Rockwell Automations, and Paul goes through a lot of information on that entire process. So that's something that I really recommend everybody check out in the future. So keeping it short and quick and trying to stay on time. We're excited to have been involved with numerous projects throughout the years. I can proudly say that in terms of all of the water research institutes throughout the continental US and the territories, that the West Virginia Water Research Institute is one of the more successful institutes because we do have great leadership. We get involved and really go after external funding to support our mission and ultimately improve water quality within the state of West Virginia. So with that, I'm going to turn it over to Tim, and feel free to shoot me additional questions or reach out and let us know what you guys have. Thank you.
All right, Timothy.
Becca, I'm not sure if you're sharing your screen. We're seeing not the full screen slides.
Yeah.
Thank you. I'll keep working on that, but yes, Timothy, the floor is yours. I'll get that.
Good morning, everyone. Thanks for joining us. This is pretty cool. I really enjoyed the seminar series that the Water Research Institute does, and happy to be a part of it. As said before, I am the state's non-point source program coordinator. I've been in this role for approximately 10 years and been in state government a little over 20. Prior to the non-point source program, I was the Save Our Streams coordinator, and also did a lot of volunteering on my own. I worked for NRCS and FEMA briefly, and have been involved in water a very, very long time. So what we're going to touch on is West Virginia and 50 years of the Clean Water Act, which is a pretty tough task. It's going to scratch the surface, talk about what we've done, how we're doing, how could we do better, and just touch on a few programs that are involved in this process. Next. Okay. One of the things that I think is interesting, and you might not think about this, is West Virginia is a water-rich state. Our water resources are abundant. I mean, you think of, when you think of things like that, you think more of coastal states, but we have a lot of water. And there's a box in the upper right-hand corner that gives you some stats. Over 50,000 miles, 50,000 stream miles, almost 25,000 lake acres, and 775 Huck 12 size watersheds within the state, more than 10,000 named streams. There's a lot that goes on in our water resources. Next. So I wanted to ask the question, how are we really doing? And, you know, there's not a lot of resources out there that tell us the story of the last 50 years since the Clean Water Act. But lucky for us, there was a study that was done in 2015 by the Interstate Commission of the Potomac Basin and West Virginia DEP, and we looked at our 26 ambient monitoring sites across the state and did a lot of different statistics and tried to determine if we are seeing trends, long-term and short-term trends. So I'm going to talk about that study a little bit. It's very, very technically detailed, and I am not going to go into the new issue, to all those details, but we'll touch on a few things and just give you an idea of how the water is doing to this point, or at least from about 2015. Next. As you can see, the text in the corner says almost all stations are increasing for alkalinity, pH. They're decreasing for phosphorus, total suspended solids, and most of the metals. Short-term trends are a little bit wacky. They're a little bit mixed in places, but hardness is better, dissolved oxygen is better. Fecal coliform is a little mixed. Some places it's better, some places it's worse. And other things are just kind of stable. Next. Okay, as you can see, this is a very busy slide. These are just a few. This is an example of the table from the report and a couple of different graphs. And I'm just going to read some of the summary data that was collected in the report. And certainly we can ask questions when that time comes. There are 6 stations that had fewer significant changes. In other words, they didn't really change much over these 50 years. Actually, I'm sorry, the study length was 43 years, not 50 years. So not quite 50 years, but it's been a long time. The Capon, the South Branch of the Potomac, the Shenandoah, the Greenbrier, the Elk River, they all have been relatively stable for a long period of time. The pH has dropped in the Ridge and Valley section of the state, which that's the Eastern Panhandle. Started in the early 70s and continued throughout the 80s, and then started to rise again over time. The suspected culprit at that period of time was acid deposition, but that is beginning to improve. We're seeing steep rises in pH in the Cheat and the West Fork, and Melissa mentioned the primary reason for that, and that's a lot of the passive treatment that's been done in the past 40 years. We also are seeing, well, one of the clearest patterns that emerged in the study is a little bit of a disturbing pattern. Basically, total dissolved solids, conductivity, and sulfates are all rising in mining regions of the state, and that's in the central Appalachians and the Allegheny Plateau. Now, the Coal River and the Tug Fork are exhibiting the highest concentrations, but there are other watersheds that are also rising. Now, since 2015, the good news is that that pattern seems to be shifting just a little bit. Next slide. So what else are we doing? Well, there's a lot of monitoring that goes on. There's TMDLs, which are total maximum daily loads, basically a pollution budget. And I'm going to talk about that program for just a little bit. I'm not a TMDL person. I do work with the TMDL section, but if you want more detailed information, I can certainly connect you with the right person. But just a few highlights of the program. The longest running part of the monitoring has been the ambient water quality monitoring stations, which, as you can see, date back to the 1940s. We've been doing fish community assessments for a long time, benthic Becker invertebrate surveys for a long time, and various other things since the late and early 90s, you can see on the screen. The newer efforts in the 2000s are stormwater samplings, trout surveys, long-term biology and habitat monitoring, specific AMD monitoring, and then more recently, some wetland monitoring and assessment, and really looking at algae patterns in certain areas of the state, which tend to be rising. Next slide. The other thing about the TMDL program, it's had some history too. Had a rocky start. There was a consent decree that came across. So West Virginia was sued for not addressing appropriately our water quality concerns. And so the TMDL started. EPA was the one who prepared many of our early TMDLs, and then West Virginia started doing it in the early 2000s and have done, in my opinion, a better job than EPA, a lot more detailed approach in the TMDLs to this point. There's been over 9,000 TMDLs completed. Currently, we are working in the Tug, we are working in the Little Kanawha, and in the future, we're planning a TMDL for the Capon and some of the Potomac direct drain watersheds in the Eastern Panhandle as well. The map on the right-hand side kind of shows you our coverage so far, and we have worked in most parts of the state. Now, there are some places, that map's a little confusing because there are some places that don't require a TMDL. So, but that is our progress so far, and it's not too shabby. Next slide. Another important part of our process to maintain our water quality is our National Pollution Discharge Elimination System program. And we've had primacy since 1982. There's a lot of work that goes into permitting and trying to get these industry people in line. And Melissa touched on a lot of the work that Water Research Institute has done. That was pretty impressive. It still is pretty impressive. And the permit team here at DEP works really hard. There's a lot of conversations that occur. There's a lot of across the aisle work that occurs. They work with environmental enforcement, watershed assessment branch, water quality standards, state revolving fund, all kinds of different people and process are involved in that. And again, I'm not an NPDES person, but there's a lot that goes on. And I wanted to talk about this a minute because this was one of the things that happened when the Clean Water Act came on board in 1972. NPDES permitting was a big part of the early Clean Water Act and still is. Continues to be successful. Next slide. So how are we really doing? And because this is part of my background and because I kind of have a passion about this, I believe knowing about the habits and struggles of the benthic macroinvertebrates is key. So how is a life doing in our rivers and streams? And this map was put together a few years ago by John Wirtz, who was the Watershed Assessment Branch manager, who is now retired. And what you need to know about this map is the grays and the greens are good, and all the other colors, not so much. So life in West Virginia in the creeks and rivers and streams are doing okay in a lot of areas, but there's a lot of areas that need some help. And a lot of those areas have to do with our acid mine drainage problems that are consistent. The issue with a lot of these things is once we mess something up, it is very, very hard, and it's a very, very long process to restore it. So it's easier to mess it up and a whole lot harder to restore it. Next slide. So we're going to switch gears a little bit and talk about primarily non-regulatory means for helping the waters, and that's voluntary action, local involvement, and a lot of coordination with a lot of different people. We have a few tools here at DEP, and that are coming mostly from the 319 program, but there are other tools as well. The biggest tool that we have in our arsenal is the watershed-based plan, and those come from primarily information from the TMDLs. In West Virginia, we have 44 plans. About 75% of those plans are active. The majority of them address bacteria problems from agriculture and other areas of the state. Fecal coliform issues are climbing, and those are the focus of most of the plans. But as you can see, acid mine drainage is a big part of that process too. Next slide. So this results in years of planning, years of project implementation, and sometimes there's some success. Here's a slide that shows all of our success stories since about 2006. There's a lot, and it's something that we want to do every year is publish a success story of some sort. Most of these focus on watershed restoration, ecological successes, and you can see a few in recent years. Muddy Creek, the lower Cheat has been doing really, really well. Fish are migrating, fish are spawning. And one of the stories I'm excited about that'll come out later this year is the Woodrow Wilson Wetland Restoration Project, which was a major facelift for the school, and the wetland is doing wonderful and is making strides in reducing fecal coliform. Some other successes that are worth mentioning are the West Virginia's pilot program, which is we got a little bit of money from enforcement actions to pay for watershed organization staff. You know, I can't really say enough about volunteers and what they do, but the jobs that are required for this restoration to take place, especially from a lot of these funding sources, require paid staff. And one of the reasons watershed associations have a difficult time is the work is difficult. It takes a full-time person, and we've got to find ways to figure out how to pay these people because they do outstanding work. The other thing we did this past year is a socioeconomic survey in the Second Creek watershed, which is in Greenbrier and Monroe County. And we wanted to learn from the farmers, what do they thought of conservation practices? What do they thought of the conservation programs that are out there? And we learned a lot from that economic survey, and that's on DEP's website. I'm happy to share that. We can always learn from our mistakes and our successes as we go forward. And finally, there's something called Cypress funds, which is a part of a settlement from the water spill that occurred in the Elk River in 2014. And there are multiple watershed groups that are receiving right around $100,000 to do project implementation, and that's pretty exciting. Next slide. Just a snapshot of the non-point source program for about 30 years now. It's you know, it's just kind of showing you where we are, how much pollution that we've reduced. The success story highlights. We spend about $140,000, $140,000 per project, which is not a lot. Most of the time, these projects are done in phases because we don't have enough money to do a complete project. So we work with our partners for a very long period of time to get these projects implemented. Our annual allocation is about 1.8 million, and that's gone up and down through the years. Congress is a little fickle from time to time, and things get cut. And sometimes sometimes we get a little bit more money. So it's a little bit of a balancing act as we move forward. Next slide. Very busy slide. This is a sort of a shout out to watershed associations. This is something that is actually a handout that Martin Chris put together that talks about some of the resources like Water Research Institute, River Network, DEP, Conservation Agency, West Virginia River Coalition, and others. Again, a shout out to watershed associations. They are diligent people, they're dedicated people, they do outstanding work, and nothing happens locally unless you have boots on the ground. Next slide. Some feel-good photos. A few pictures of things that's happened, some before and after. The upper right is Muddy Creek, and that was mentioned. And there's the treatment system was mentioned, and the results are very promising. And it looks like there's going to be some delistings up in that part of the world pretty soon. The lower right is a project that we did many years ago on a farm in Berkeley County on the Conley property. and restored that stream. About 2,000 feet of stream was restored. Benthics are coming back, fish are coming back, and there's a lot less erosion in the stream and downstream from there. A couple of shots of stormwater projects, porous pavers, and you can't do anything out there in the world, in our world at least, without involving kids. So I think that's a special part of this as well. Next slide. Some more feel-good photos, and just to let you know that we still need help. We need people involved. We need funding. We need a lot of things. So we want to know what you think. We want to learn from your experiences, and we want you to be involved. We also want to examine ourselves and learn how to be better. We want to know how to be better. We want to do more, sometimes with less. And we want to know how you want to help us protect and restore our abundant water resources. In the past few years, what's been exciting trend is people getting out on the water and recreating. And we can't have that without clean water. So there's been a lot of water trails. The Coal River group kind of started it all off, but there's been many since then, really focusing on our flat waters, but there are other water trails as well. There's one in the Guyandotte, which didn't used to be a nice place, but it's a lot nicer now. There's one on the Elk River. There's a new one starting in Tug Fork, and there are many, many smaller organizations out there doing the same thing. So people are really excited about our water resources, and they want to take advantage of the fishing and the rafting and the kayaking that's out there in West Virginia. We have some marvelous waters to do so. And I do want to mention, while I was putting this together, that I came across a lot of different resources, reports, studies, all kinds of things. And what I would like to do for the people that are participating today is put together a packet, if you will, and of information that includes some of the summary information I included. It would include this presentation among some of the other resources I collected from doing this process. So just send me an email and I'll get those to you. Thank you very much, guys.
Right. Thank you so much, Timothy. Emily, you're up next.
Let me try to share my screen here. Can everybody see that?
We are.
But we can see your slides, like the slides on the, oh, now you're good. You're good.
Okay. So I might be giving a little bit of a more focused water quality overview for USGS today, just because this is kind of the work that I work on. I'm a researcher out of the Pittsburgh field office, and I do a lot of emerging contaminants research. So at one point it was hormones, and then it was certain types of pesticides, and now the hot emerging contaminant topic is PFAS. Funny that they're not really an emerging contaminant class, but it's definitely something that we're putting a lot of effort in at USGS to understand. So I'm going to kind of give you a little bit of an overview of the projects we're working on related to PFAS forever chemicals in Pennsylvania, some of which are in southwestern PA in waters that do drain through to West Virginia. So some relevance there. And one of our sites is even the Ohio River at the Newell Toll Bridge. So right on the border of West Virginia and Ohio. But I wanted to start, just USGS in general does a lot of water quality research. So we're really interested in clean water in terms of potable water, in terms of recreation, and also just habitat. So there are researchers across the agency working on these clean water questions. In Pennsylvania, we have a water quality network that the Department of Environmental Protection has established across the state. So it's 178 stations, surface water stations nationwide, and the USGS helps sample around 130 of these sites. And we sample these sites either on a monthly or bi-monthly basis, and they get analyzed for nutrients, metals, ions, and then we can take this robust sampling network and zoom in on certain locations and do more refined studies like on pesticides or PFAS. So this is a really neat resource, this network, and it's great to be able to tap into it to answer specific water quality questions. So the figure that I'm showing on the right, this is actually from our 2019 PFAS study that we did. It was a statewide study, a one sampling event, and the lighter triangles in white are kind of the no detects of total PFAS, and then the darker black triangles are where we saw some high hits. This is preliminary. It's in review right now at a journal, but you can see there's some hot spots in southwestern PA, kind of the Mahoning Beaver systems. And then there's some hot spots in southeastern PA near Philadelphia, where we have a lot of kind of known sources of contamination. So the beauty of this network is we can really sample a good spatial distribution across the state for any water quality suite and really kind of focus in and answer specific questions. And again, most of this is in collaboration with the state DEP. But today I kind of want to dive into some of the breadth of PFAS work that we're doing across the state. Should probably quickly introduce PFAS for people that haven't heard of this class. So it's per and polyfluoroalkyl substances. So they're these carbon fluorine substances that are really hard to break down. Been discovered in the 1930s. They've been around for a while. Every time I see a PowerPoint, one day it's 4,000, then it's 5,000. Sometimes there's 9,000 of these chemicals. So we're constantly discovering new fluorinated compounds that are out there. They're typically used in kind of non-stick materials, firefighting foams, any kind of waterproof Gore-Tex material, stain resistant, food packaging. So there's a lot of uses. They're kind of sadly just everywhere. So this is kind of the class, and a lot of people are working on this. So one of the big challenges with studying PFAS chemicals, and this is something that the USGS kind of prides itself on, is developing really good standardized protocols for different classes of chemicals. So with PFAS, you can imagine, I just mentioned a bunch of uses, any kind of fluorinated plastic, that's going to introduce contamination. So we work really hard to develop methods to sample surface waters and groundwaters to not introduce contamination during the sampling process. So that's been a huge effort out of Pennsylvania. We've kind of set the stage nationally for how this type of sampling should be done and what types of materials should be used, and even the gloves that should be worn. Some methods you might read really limit clothing that you can wear and even what you can eat the day you're sampling. And we don't take it that far, but we definitely have established methods with HDPE equipment. We wear 2 sets of gloves and usually use a clean hands, dirty hands process. So 2 samplers go out. One person is touching the clean sample bottle and one person's touching the sampling equipment itself, and then kind of pours the water into the clean sample bottle. So there's a lot of thought that goes into this method. And then we use a lot of replication and blank sampling to ensure that our method's producing quality data. This was a multi-year effort, I'd say, to establish this protocol, and it'll be published in the near future. So the kinds of questions that we're trying to answer at our center. So we have a monthly sampling campaign for PFAS, which is at 16 sites across Pennsylvania. 7 of those sites are in southwestern PA, and that was the one I mentioned that's on the Ohio River at Newell. So we're trying to capture, again, kind of a spatial distribution across the state near some known sources. So looking for seasonality differences, concentration, mass differences. We usually get a discharge measurement at every sample so that we can look at that mass difference. And just what types of compounds are we seeing across the state? We're starting to notice a different signature in PFAS chemicals in Philadelphia versus PFAS chemicals in Pittsburgh. So picking up on those types of trends. This data will be publicly available. We're just now trying to get a lot of this posted on our database. We've participated in what we call a river continuum sampling effort. So this is a single day event where we sample upstream and downstream of known PFAS sources. This took place in southeastern Pennsylvania, trying to follow kind of the same piece of water as it moves downstream. So if we can see mass differences in that sampling effort and kind of tie that mass change to the known source input. So we looked at PFAS, pharmaceuticals, organic carbon, Major ions, this was a huge effort over really a day and a half, because you have to time that water piece using velocity and certain equations to figure out when it's going to be at each sampling point. So this is data that we're working through right now. Again, just trying to tackle source attribution of contamination. Another study that we're working on in southeastern Pennsylvania is looking at surface water foams. So whether they're naturally formed from organic matter and proteins, or if they're formed from potentially PFAS itself or other surfactants, and looking at kind of the concentrations of PFAS in these surface water foams. So we know that they can act as a temporary sink. We've seen concentrations in the thousands per nanograms per liter, which, to give you some context, typically in surface water, we'll see 10 nanograms per liter, or maybe in the hundreds, but to see thousands is a pretty significant concentration spike. So we're looking at different foam bodies in southeastern PA near known PFAS sources. So that's a study that just started in the last year, and that'll be a 3-year effort. Another study we're doing is in PFAS and unconventional oil and gas waste study. So this is wastewater treatment plants that accept UOG waste, and we're going to sample upstream and downstream of the treatment plant to see if there's an increased input in PFAS compounds in the downstream effluent from these plants that we know take UOG. So this is a collaboration with the state DEP. That's how we really kind of identified these key sites. And I know at least 2 of the sites are in southwestern PA, kind of in that same Mahoning Beaver system that I mentioned earlier. And that sampling effort just started this week. So this will be a really interesting data set. They're going to sample these same locations quarterly. So we'll have some seasonal differences to evaluate as well. And then finally, another PFAS study that we're working on in southwestern PA is looking at PFAS in surface water around the Pittsburgh Air Reserve Station. This is also near the Pittsburgh Air National Guard and near the Pittsburgh International Airport. So all 3 are known PFAS sources, but this is funded specifically by the Air Force Civil Engineering Center. So we'll be monitoring 18 sites around the Air Force base, and mostly surface water with the potential for future groundwater. This will be a 3-year study. And we will be focusing on PFAS, nutrients, major ions, and glycols. So we've got a lot of work going on in this sphere and all across the state. And it's kind of, like I said, this emerging topic. So when we think about water quality, we obviously have lots of different things we could be studying. And right now, this is kind of one thing we're really focusing on. And my last slide was just the link, which I can put in the chat, to that statewide data set in case anybody wants to dive into that data. So all of our data is publicly available. And if you want to dig in and look at that closer, I'll post that in the chat. And that's all that I have.
Thanks, Emily. I'm going to help facilitate the question and answer session. If you want to stop sharing your screen, there we go. Everyone, feel free to unmute yourself, turn your camera off, post in the chat if you prefer to ask questions that way. But I can kick things off. I know we had a really wide variety of presentations today, and thank you to all of our presenters. That was excellent. We talked about permitted discharges and working with industry. We talked about really wide trends in West Virginia and non-point sources and more. And we talked about emerging contaminants with PFAS. So a lot to talk about. And the question that I have for any of the speakers is thinking about the Clean Water Act and celebrating the 50th anniversary, and also with the bipartisan infrastructure law money coming out. I'm kind of curious your perspectives on the impact that you think that will have. Is that comparable to the Clean Water Act? And just really what your thoughts are. So I'll leave that to any of the speakers, and feel free to chime in with other questions afterwards.
I'll jump in. I think we're going to have a hard time finding construction crews.
Yeah.
I'm worried about the labor behind, all of this money coming down and how we're actually, we can plan it and you know, look towards implementing things, but I'm worried that we're not going to have enough construction crews to do remediation projects.
I would agree with Melissa. We've seen over the past 4 years, basically since the pandemic started, that construction crews have been hard to come by. And not only that, there's been supply chain issues for all kinds of things you wouldn't even expect. And in terms of this infrastructure money, it's exciting when we get investment in our communities, in our country. But oftentimes when you throw a lot of money at it, it doesn't end up in the right places. And that is a concern of mine. There's also a lot of strict requirements that's associated with that people are not aware of yet. And I'm just learning about from my program in the state. So it's going to be complicated, but I'm still trying to remain positive. That's one of my goals for the upcoming years, is to be a lot more optimistic about things. So hopefully things will go pretty well.
Yeah, I can also build on from that labor perspective, and the construction perspective will be important. And also just having a science force to get out there and do sampling and evaluate the effectiveness of some of these practices that are implemented. I know we're all feeling short-staffed on our end, and the supply chain issues as well. So even just getting people out there from this end too is challenging.
All right, any other questions for any of the speakers or discussion points about the Clean Water Act? I know there were a lot of really good resources that were put into the chat, and yeah, Emily just added the article on PFAS. So feel free to check those out. We'll probably send them out in an email as well if you miss it.